said an acid is a proton donor, and we said a proton is again a hydrogen ion, and a base is a proton acceptor. Okay, now we are busy showing that, giving an example. The following equation, we have hydrochloric acid with ammonia, and that gives you the ammonium ion and chlorine ion. Okay, what we did after that is we paired them up to the things that looks the same. And when I say they look the same, they're not equal, they're not identical. This is chlorine, chlorine, nitrogen, nitrogen. So I do not look at the hydrogens. Okay, now from here to here, what happened? Fatima. It lost? It lost what? Yes, can you see that? It lost a hydrogen. Yeah? What happened? It gave its hydrogen to ammonia. Okay, so if something gives away a hydrogen carbon, what is it? An acid or a base? When it gives. So that gave away its hydrogen. So that we call an acid. Right. Now remember, this is a reversible reaction. Meaning, from here we can go back that way. Okay, so you can read it either forward or you can read it backwards. So if we read it backwards, chlorine ion, and then it becomes hydrochloric acid. What happened from there to there? Okay, so is that thing then an acid or a base? A base. Now that name of that base is not just base, it's called a conjugate base. A conjugate base. That's his name. A conjugate base. Alright. Let's look here. Ammonia. When it went to the ammonium ion, what happened, Refilu? A what? So it's an acid or a base? If it gained a hydrogen, it's a base. It accepted a hydrogen, so it's a base. If we read it the other way around, from ammonium ion to ammonia, what happened that way, Bortley? So it is a? Yes, a conjugate acid. Okay, so we call them conjugate acid-base pairs. Conjugate acid-base pairs, yes. Say again? Yes, so, but this can also, if you read the reaction other way around, then you'll say, this is the acid, and this will be the conjugate base. It depends what you start with in your head. Alright, so, they love to ask this question, grade 11 and grade 12. You must be able to identify this acid-base pairs, but it is actually quite easy, because on the left-hand side, you must have an acid and a base. You can't have an acid and an acid. Okay, and then if this one is an acid, then its friend will be a base. So if you can identify at least one of them, then you should be able to identify the rest. Okay, what's this thing's name? So if its name is acid, then it is an acid. Then you know this is base. This must then be an acid. This must then be a base. Okay, right. Now let's read. It says there, but the reaction between an acid and a base entails the following. There is a proton transfer. The hydrogen, the proton is transferred from the acid to the base, and it's called a proteolytic reaction. A proteolytic reaction or protolysis. Have you heard about electrolysis? Yes, that is where an electron is transferred. So where protolysis is where a proton is transferred. Then equilibrium is reached. Okay, now equilibrium is because there's a reversible reaction. You can go forward and back and forward and back, until it reaches its balance. Equilibrium is reached, and that is determined by the relative strength of the acid and the base. If it is a strong acid, then what is the definition of a strong acid? Turn back in your notes. The definition of a strong acid. Strong acid. Okay, so a strong acid, and that is a strong acid, will give you a lot of products. So if this is a strong acid, then it means our equilibrium will be slightly to the right hand side. Okay, so that's just what they mean there. Then the formation of acid-base pairs forms, which are called conjugate acid-base pairs. And then some substances can donate or receive a proton. And they are called amphiprotic or amphiolites. Sounds like what, Bukamuso? An amphiolite sounds like what? Do you take life sciences? Who takes life science? Sounds like what, Mr. Life Science? An amphiolite sounds like what? A frog is an example of that. Amphibian, because what can a frog do? It can help you, alright? Yes. Okay. It can hop and swim. Okay, but that is not what we want to show. Amphibian can live in water and it can live out of water. Okay? So an amphiolite can be an acid or it can be a base. It can donate or it can accept. Okay, right. Let's look at these pairs. Okay, hydrochloric acid will react with water, and Bukamuso, back to you. What will form? What's wrong? Must I bring the sweeties back? Yes. You'll get 0. Why? It is balanced. So what? Because it gained, sorry, from here to here, it gained a hydrogen ion, so it gained a positive thing, so it becomes plus, and this one then lost a positive thing, so it becomes negative. Now we have to make acid-base pairs. Okay, put up your hand if you can tell me. Yes, for me. Sorry?
The hydrochloric acid, the acid is a rate, and the HEO plus is the control. Conjugate. And the other one is a base.
What other one?
H2O, water is a base. And chloride is a conjugate base.
Oi, wait. Good. Okay, next one.
It's too hot.
What will form? Yeah, Monday. Mooi. Acid base pairs. Oh, sorry. Yes, begin met zo. Ja, doe maar. Kijk, di makatso. Ach, di makatso ore suwe. It's wrong. Ja? Right, shush. Are you not answering? Karabu?
Ammonia, NH3 is a base
Why?
because it's receiving a hydrogen ion. And H2O is a base. The acid. And then in the other ammonium that we see the hydrogen, it's a conjugate acid. And the other is a conjugate base.
Now we have a problem. How is that possible?
Yes. Water is
Amper gooi ek vir sy naam daar. Sorry.
It can donate or it can what?
Yes, accept.
See.
So, here we have a list of amphiolites. Water is our first one. Water can either receive to become the hydronium ion, or it can lose to become the hydroxide ion.
This sum is in the bed.
Okay. Right, next one. There's a mistake in the next one. It must be fluorine negative. Okay. Anyone ready? Nee, maar 'n bietjie iemand anders. Watermelon, Tazwar, Refilo. Jy kan probeer? Wat? Hmm? Do you know how to pair them up?
Yes.
When they look the same, more or less. Okay, anyone wants to try? Klono?
Ma'am, NH2O is an acid.
No. Yes. Yes, yes.
If negative is a base, NH3 is a conjugate. Conjugate base, and HF is a conjugate acid.
Wait. Ooh. Sorry.
Are you cricket teacher?
Am I? Not at all. Alright. Then the next one, we see we have sulfuric acid. Alright. Now, sulfuric acid, as you can see, can give away 2 hydrogens. So that is why it can ionize, it can split up, form in 2 steps. So we're going to have a 2-step ionization process. So you're going to have a 2-step ionization process. Okay. So, in the first step, you're going to take sulfuric acid. It's going to react with water. And then 1 hydrogen is going to go to water and it's going to form a hydronium ion and the hydrogen sulfate ion. And then in the second step, you're going to take this hydrogen sulfate ion and it's going to react with water again because it has another hydrogen that it can give away. Okay, it's not done giving away. Here it only gave away 1 hydrogen and now it has another hydrogen that it can give away. And it forms another hydronium ion and then the sulfate polyatomic ion. So it can ionize in 2 steps, or you can write the net reaction. What's wrong?
From that H, I'm from number 4, right? H is not 4, to number 5. You just please repeat that number.
Okay, so you take that thing. So it still has another hydrogen that it can give away. So now it gives away that hydrogen to form another hydronium. And now that hydrogen is gone. So now you have a sulfate left over. Okay, so you can either show this in 2 steps or you can do it in 1 step together. That we will call the net reaction. Now in a net reaction, like in mathematics, if we have x plus 2 is equal to 12 and 15 minus x is equal to 5. Right? Then you can add them together. Yes? Okay. Now the same thing we are going to do here. We're going to add these 2 things together. But when you do that, you check what can cancel out on both sides. Okay? Is there anything that is the same on both sides? H2O is only on the left hand side. HSO4. So it can cancel out and then we can write down this plus 2 of that gives you 2 of this and that. So you have sulfuric acid plus 2 waters gives you 2 hydronium ions and sulfate. Okay, so let's just check. So we have that plus 2 of that gives you 2 of those and that one. Because these 2 things cancel out. Yes. SO4, it's not SO4 2. There's no 2. Or that one. There's a lot of reasons. If you look here, H2SO4. What is hydrogen's valency? But there's two hydrogens, so it must be plus 2. So what must that thing be together? No, it does no. Carbonate is also 2 minus. Phosphate is 3 minus. SO4 is 2 minus. Always. Always. Alright. Here's my conjugate acid-base pairs. Yes, please. Why? Someone wants to try the next one? Yeah. Karabu.
The first one is a base.
Why do you say that? Why are you looking at the top one? You must look at what is the Lowry-Bronsted definition. What happens from there to there? So it is then?
Conjugate acid.
Uh-huh. Alright, so give me another example of an amphilite in this reaction. ¿Qué es Pugamuso? H? H? No? Sinumta? HSO4. Because it can become H2SO4 or it can become SO4 2 minus. Alright? So be careful. If they ask you, give an example of an amphilite, are they saying in general? Then you can give water, whatever. But if I ask you, give an example of an amphilite in this reaction, then it's not water. Water here acts as a base and a base. In this reaction, it is hydrogen sulfate ion. Okay. Few things I want to say here. Alright. Then you can see here, it gives away 2 hydrogens. Right? In the net reaction. What is the prefix for 2 in science? Di. What's the prefix for 1? Mono. Okay, so this is a diprotic acid because it can give away 2 hydrogens. A diprotic acid. And a diprotic acid that can give away 2 hydrogens will need 2 waters to form 2 hydronium ions. It's always like that. So if that is 2, then this must be a 2 and this must be a 2. If you have a triprotic acid, this one is triprotic, then you'll need 3 waters and 3 hydroniums. A monoprotic acid will need 1 water, 1 hydronium. Okay. Then you have 3 more amphilites. One of them is this one. The bicarbonate ion is the hydrogen carbonate ion because it can form carbonic acid or it can form the carbonate polyatomic ion. Another example is hydrogen phosphate. So it can form the phosphate polyatomic ion or it can form the hydrogen phosphate ion and that again can form phosphoric acid.
Are those all the ingredients that you mentioned?
Amphilites. Right. Then on to the next page. So this here is just a quick summary again. What is an acid? An acid gives away a proton, but a strong acid gives it away easily. Now this here is informal definitions. Okay, so this is not a formal definition. This is just like a help you to remember. An informal definition. Strong acid ionizes completely to give a high concentration of hydronium ions. Yes. And weak acids does not give away the proton easily, or it ionizes incompletely to form a low concentration of hydronium ions. Okay. Then you can skip this part for now. Okay. Then we've done this before in a previous chapter, but I quickly want to do it again. The ionization of acids and the dissociation of bases. Ionization is where it reacts with water. And this is reversible reactions. Okay, what will form in the first reaction? Yes, Bondley. Okay, begin so. Oh, say again, sorry. H? It's the same question as Nana. Okay, next one. Yes, yes, Nomta. Just like that. Okay, and the last one there, I want the net reaction. And no, you just answered. Bondley? You sound. Huh?
I have a rule whenever I finish finishing that second class I teach.
You have that rule. Is so? Right. Then dissociation is where it splits up in the presence of water. All right. What will form? Put up your hand. No, you just answered. Yes.
Is it H3?
No. Yes. What's OH's name? Iron. Next one? Yes. Oh, sorry. Yes.
K plus and H2 minus OH.
All right. Now I've discussed this already. This is just in your notes now. We have monoprotic and diprotic. Monoprotic means it gives away one hydrogen. Diprotic means it gives away two hydrogens. Then you get monobasic, means it gives off one hydroxide, and dibasic means it gives away two hydroxides. All right, so grade 11. So you're going to start now. You're not going to pack away. You're not going to sit and do nothing. Your homework is question 1 to 6. 1 to 6, and you're going to start now. You can finish it on the next page, page 10. All right. For question 1 to 4, you're going to need either this formula or this formula. Okay. 1 to 4, you're going to need those formulas. Then remember, cubic centimeters is the same as cubic decimeters. Not the same, sorry. It's the same as milliliters, and cubic decimeters is the same as liters. How do you go from milliliters to liters? Right, then they ask you there for the ionization reactions for these ones. And then the dissociation for the bases. For the ionization, here you see you have a diprotic acid and a diprotic acid. For both of these diprotic acids, I want to see step 1, step 2, and the net reaction. For this one also 1, 2, and the net reaction. You now have 15 minutes. Go.